Welcome to my today's class. I am so excited to meet us again in this channel. Okay, today I'll be taking us on some Olympiad questions and how you can answer them. Okay, so you are welcome to Rosy Math class. Welcome, welcome, welcome. All right, the first question I have is on indices. Indices. And we are asked to simplify. We have a fraction. We have x over the square root cover x and then another root x. Okay, so we are to simplify this. We have options. Option A, option B, option C, and option D. Okay, and then E, we are saying that none of these. Okay, so let's solve. Do we have an answer there? Is it option A? Is it option B? Is it option C? Is it option D? Oh, no answer at all there. So let's work it out and see what will happen and how you can answer this question. All right, I'll be looking at a solution to the problem, and this is how I solved it. It's already solved, so I'm going to show you what I did. So what I did is, in place of the root sign now, the square root sign, I'll be using the fractional sign, which is 1 over 2 for square root. Okay, so I have this square root now. I will have 1 over 2, that is the 1 over 2 outside the bracket. And then for this particular square root, I'm having 1 over 2 for this x, the second x in the bracket. Okay, so I'll open the brackets here and I have x equals x raised to power 1 over 2, and then x raised to power 1 over 4. 1 over 4 is as a result of multiplying 1 over 2 by 1 over 2. So with that now, I apply the law of indices here because they are of the same base. So the bases are the same. I'll select 1, and then the power here is 1. The power of the numerator is 1. I'll subtract the power of the denominators from this numerator. So I have 1 minus 1 over 2 minus 1 over 4. Okay, so I will make that a single fraction. Okay, so this is how. So find the LCM and then just making it a single fraction. So the LCM is 4, then multiply, have 4 minus 2 minus 1, and that ends up giving us x raised to power 1 over 4, x raised to power 1 over 4, and that is our final answer. So what option is that? It is option C. Okay, so the answer is there and it's in option C. Okay, our second problem will be on simultaneous equations. We have two simultaneous equations here. We have a quadratic equation and we have a linear equation. So we have option A, option B, option C, option D, and option E that is saying none of these. Okay, so let's see, do we have an answer? And if we do, what option has the answer? Okay, what option has the answer? So let's go. Okay, solving the simultaneous equations, we have the two equations. My first equation is the quadratic and my second is the linear. Okay, so what I did is from the linear equation, that is equation number 2, I made y the subject. Okay, in making y the subject, you will see it here. I made y the subject and then I have y equals 2x plus 9. Okay, so that will now help us to solve the equation. So I use substitution method, and I substituted y equals 2x plus 9 into equation number 1. So in place of y now, I'll be having 2x plus 9. Okay, so this is it. Okay, so sorry I was a bit fast, so but I will explain. So I have x squared is still there, plus 2 plus 2. But in place of y now, I'm having 2x plus 9. still square. Okay, so still square equals 59. So we changed y to 2x plus 9 because from equation 2 we are having y to be 2x plus 9, and we want a situation where we will have one variable. Okay, so I opened the bracket, solve, and I have simplified, and I have x squared plus 8x plus 12 equals 0. So I have my quadratic equation of one variable. Now I can use any of the methods to solve for this quadratic equation. I can use the formula, I can use a factorization method, I can use completing the square method. So that is what I did to get my answer. Okay, so I'm having x now is minus 2 or minus 6. That's the value for my x that will satisfy this equation. So it's either x is minus 2 or is minus 6. So with that now, we can now work out to get the value of y also. So doing that now, we have when x is minus 2, y is 5. Okay, that is it here. And when x is minus 6, y is minus 3. So let's go back to our options and see the one that satisfied this problem. So we can see the answer is in option C. Okay, is in option C. You can try it yourself and make your comments. Okay, this our next question is on sequence, and we have that the sum of the first n terms of a sequence is n. The first bracket open, we have n plus 1 close. The second one, n plus 3 close. Okay, and we are asked to find the 10th term of the sequence. We have our option A, option B, option C, option D, and option E. So let's work this and see the one that is correct. Okay, the solution we have here. Now, you should note first that the sum of the first n terms of the sequence is given as n, brackets open, n plus 1. Then another bracket, also we have n plus 3. Okay, so this is the sum of n terms. Okay, so what I did is, okay, since I'm looking for the 10th term, okay, I'm looking for the 10th term. Okay, I will take the sum of the first 10 terms, okay, and subtract the sum of the first nine terms from it. The sum of the first 10 terms minus the sum of the first 9 terms. By doing that, the 10th term will just be all alone. So substituting, I will have in place of n now, let me show you a pointer. In place of n, I will have for the first 10 terms, I'll have 10 brackets open, 10 plus 1 close, then another bracket open, 10 plus 3 close, minus for the sum of the first 9 terms, I'll have 9 in place of n. Then the first bracket open, I have 9 plus 1 close. The second bracket, 9 plus 3. Okay, so with that now, I will just do my arithmetic, and I will have 1,430 minus 1,080, and that will give us 350. So that tells us that the 10th term is what? 350. So what option? Option B. Option B is the right option. All right, this next question is on set, and we are asked to find the number of the subset of an n-element set. N-element sets. Okay, we have our options here. Okay. N-element sets. So let's work it out. Okay, for this problem, all I want us to note is that the number of all subsets of a set is equal to the power set of the set, period. So what is the power set of a set? The power set of a set is equal, is 2 to the power n. Okay, 2 to power n. How many elements are in the set? That is what n is. Okay, how many elements are in the set? For instance, if you have 2 elements, okay, that means that the subset of the set, okay, or the subset of the set will be 4. That's 2 raised to power 2. Okay, if you have 3 elements there, it would be 2 raised to power 3, okay, giving you 8. Meaning that you have 8 subsets, okay? So that is how you can tell the number of all subsets of a set is equal to the power set of the set, which is 2 raised to power n. Thank you. So what option is it? Option B. Okay, for this last one, we are looking at the least common multiple of fractions. Least common multiple of fractions. Okay, we have our options here. Okay, how do we find the least common multiple of fractions? Let's go. Okay, we are going to look at the solution to that problem on how to find the least common multiple of fractions. So I have 2 fractions here, 2 whole number 1 over 4 and 2 whole number 2 over 5. Okay, so let me tell you how. So I will change both to improper fractions. Improper fractions, that is the first thing. Then for the numerators, I'm going to look at for their highest common factor, and then for the denominators, I'm going to look at for their least common multiple. Okay, so let's go. So my first fraction is 2 whole number 1 over 4. Okay, this is it. So I changed it to improper, and I have 9 over 4. How? 4 times 2 plus 1. Okay, so the denominator remains the same, but the numerator has now become 9. Okay, for the second one, I have 5 times 2 plus 2, that is 12, and the denominator is still the same, 5, but the numerator has changed to 12. So I'm going to find the highest common factor of the numerators, okay, and that is 9 and 12. So the highest common factor is what can divide both of them without remainder. The highest number that can divide both of them without remainder is 3, okay, and then the least common multiple of 4 and 5, okay, is 20. So with that, now I will have my results as 3 over 20. So the least common multiple of these 2 fractions, 2 whole number 1 over 4 and 2 whole number 2 over 5, is 3 over 20. Option A is the right option.